All right, welcome everyone to this session on player tracking data. My name is Luke Bourne. I have the pleasure of chairing this session, introducing the speakers. So when I started working with player tracking data about 5 years ago, and people would always say like, oh, how come things aren't progressing? I was very much under the opinion that the reason things aren't progressing is just a pure lack of data, that people don't have access to player tracking data. And that was my go-to answer about why this area of sports analytics hadn't advanced for quite some time. But a couple years ago, when as spatial temporal data became ubiquitous across sports, and for instance, the NBA released an open API for the tracking data, and now a simple GitHub search will give you seasons of tracking data from different leagues and sports. I've become more and more convinced that it comes down to not having the right people with the right skills to dig into this. So today we're really fortunate to have three of the people that are leading the charge in dealing with player tracking data: Devin Pleuler, Nate Sandholz, and Carl Pizdernik, to talk about their work. The first is Devin Pleuler. Devin and I actually met about 5 years ago in a little pub called Parlor Sports, best sports bar in Boston. And Devin at the time, I was working here. He was coaching at that other institute down the street. And he then went on after that to spend some time at Opta. The last few years, he's been at Toronto FC, which, if you channel Mike Lopez and Ben Ballmer, we'll say have been very lucky the last year or two. So, Devin, it's all you.
Thanks, Luke. So as Luke mentioned, my name is Devin Pleuler, and I've done this work today with Brett Myers, who's sitting here, who also works with me at Toronto FC. Him a little bit longer than I have. So what I'm going to talk about today is opposition analysis, methods for forecasting style of play in soccer. Kind of a fancy way of saying like, how do we do data-driven tactical insight? So, I think this is a bit of a gap in sports analytics, particularly in soccer analytics, in terms of researching like how a team plays as opposed to why a team is successful, right? And I think those are two kind of different things, right? There's, regardless of sometimes how the method in which maybe a team is playing doesn't necessarily make them good or something else. Like we're looking for pieces of information that we can use to kind of predict how this team is going to play or your opponents are going to play, right? So one of my major kind of learnings in this space, and this is going to be a very applied talk, is I've noticed a bit of a trade-off between sophistication and predictiveness of models, and like how useful they are sometimes. So as a model will frequently get more predictive as you make it more sophisticated, right? When you're kind of inside of a club, I find that it's frequently, the more sophisticated a methodology is, frequently the more difficult it is to kind of explain that. Or, and if I have a hard time explaining that and the coaching staff has a hard time understanding that, it's going to be less and less useful, right? So striking this right balance is really very important. And I think that might be slightly kind of maybe not like an academic sort of friendly way, and I'm very much a kind of a pseudo-academic, but I think that in terms of finding ways for this to be applicable, I think it's an important balance to strike, right? So this is also kind of a convenient opinion as well, given that I'm not a PhD, and I can't really quite read a lot of the math that we've got up there today, right? But in terms of trying to make this stuff as applicable as possible, it's important. We need to build kind of socially scalable models. There's I frequently say at this kind of position I am working just as much in kind of technical engineering as I am in social engineering, right? Which is amusing, and I think for a lot of people going into first time at a club in an analytics capacity, you're frequently kind of unprepared for that social side. But what I'm going to do is kind of talk about kind of a very lean framework that we're using in terms of kind of opposition analysis that I think is really consumable and also fairly explainable and consumable. So I'm going to talk a little bit, first kind of about the data, right? So in a average soccer game, there's roughly about 1,000 passes per game, and if you're looking across a season, that's going to accumulate into hundreds of thousands of events, right? We at Opta, at Toronto FC, we use primarily Opta data, who's given me allowed me to use a anonymized data set for this piece of analysis, which is great. Each of these, it's essentially event by event data, right? So we know for each pass of these, hundreds of passes per game, where that is, between which players it is, what time at which this pass happened during the game, and things like that. And you can chain those and connect them and do a lot of different kind of creative things with it. But I very much, while a lot of talk in terms of soccer analytics is very much focused around expected goals and things like that, which is a remarkably useful and intuitive framework, you have a lot more passes per game than you have shots. And frequently I don't feel like you're doing enough with those. So what we do, or at least kind of what this research is kind of dependent on, is looking at every single pass, stripping out various components of it. So for example, in this particular pass here, we're collecting not just the distance, but also its change in X and change in Y, its origin and destination coordinates, as well as its pass angle to goal, which is represented by kind of that arc there, as well as a couple other kind of attributes that are attached to a pass qualitatively by the analysts that collect that. And what we're largely doing here is just applying a very straightforward k-means clustering algorithm, right? This is a very simple application in Python, and I tend to prefer to put code up here instead of formulas. But yeah, so what we're using is we're looking across these roughly 200,000 passes. I'm calling them open play passes. So those are non-set pieces, no throw-ins. Putting them into 50 separate clusters and categorizing them into different pass types, right? The 50 is chosen fairly arbitrarily. I'm sure there's probably a more friendly or accurate way to pick that number. I tried a handful of different things. I thought 50 worked the best, but I recognize that there probably are more robust ways to kind of pick that number. So after doing that, for example, here's one cluster, right? So this is doing a fairly good job at picking up certain passes from right around the so all the visualizations I'll show you today we're attacking left to right. So this is from kind of your own area into a pass centrally, kind of out to the wing, right? So this is pretty good. It's finding this is a random selection of I think 100 passes from that cluster, and it's doing a fairly good job, right? It's showing passes from and to about the same location, right? And the next slide I've got here is actually an animated GIF of a handful of different clusters, right? So this is doing a fairly decent job at finding different kind of pass types. The other thing you'll notice is the blue and the red here. So a blue pass is a completed pass, as determined by the analyst, and a red pass is an incomplete pass. And what you'll notice is that certain clusters will have certain kind of pass completion rates and things like that, which I think is pretty useful. Say if you're building a model for determining the difficulty of passes, this is a great kind of methodology to lean on. But what I found really quite neat about this is this next bit is how kind of these are the centroids of each of these clusters, right? So this k-means clustering algorithm is entirely unsupervised, right? But when we're looking across all these different thousands of passes, you find some really interesting things here. In particular, kind of the symmetry of a lot of these different things, right? You're finding, and I'm only highlighting just a couple of these, but this entirely unsupervised algorithm is finding some underlying symmetries and kind of fabric of the game, which I think is really pretty neat. And definitely kind of helps me kind of pass the smell test a little bit, right? Yeah, that's kind of neat. But I think that all this really shows is that, okay, this is just a decent way to kind of segment passes. This isn't really that useful yet, right? So how do we make this a little bit useful? So the next bit is to, well, I suppose you also want to look at how frequently certain passes are attempted, right? So across these 50 clusters, you range from anywhere from 15 to like 4 or 5 passes per game per cluster, which is cool. It shows that it's fairly well distributed, but there aren't just 1 or 2 clusters that are kind of taking over everything. But where we start to get interesting is where we start to look at team-by-team analysis, right? So these are the number of passes per cluster, and I've truncated it because obviously there should be a lot more than just 15 or 16 columns. But you'll look at how many passes that each team attempts of a certain pass type per game on average. And this is pretty neat because you'll notice I have this sorted by the overall frequency of passes. So the cluster number 9 there, for example, is the most frequent cluster. And as you go from left to right, you see it gets less and less. That's cool because while there is, you see some kind of underlying kind of nature of the game and that certain types of passes are more frequent, but you also do see that some teams do vary in terms of how frequently they attempt these. But how predictive is this? Can these past tactics predict future tactics, right? And what's the best way to measure this, right? And the way that I settled on was to kind of look at if you were to pick a point in the season and look at a team's performance before that, how well does that predict their future performance? So if I'm looking at the number of passes per cluster per game before a certain cutoff point in the season, how well does that correlate to the remainder of the season, right? And what I did is kind of using a sliding window here. So I'm using, say, at the beginning, the first 5 games to predict the remaining 25, and then the first 6 games to predict the remaining 24, et cetera, right? This is just a very simple kind of a mean absolute percentage error, just a very simple way to kind of evaluate your predictions versus actual. And you do see some interesting stuff here. So as we progress from game 5 to game 29, right? It's a 30-game season. The predictiveness of a particular team's past pass frequency will correlate much closer to the remainder of their season. What this is saying is that as the season goes on, teams become more and more unique, and as your sample size gets better and better, it becomes even more useful. It tails off at the end of the season simply because you don't have as many games left, because your sample size is more likely you're going to vary. Now this can get a lot better, and this is kind of just showing a bit of a proof of concept here. We're not controlling for things like home and away, right? Some teams play a much different style on the road versus they do at home and things like that. And if we adjust for those things, we can get a bit more precise, but then again also have our sample size. There's other things like game state adjustments, like okay, if this team goes up in a game early, their tactics are going to change, right? How do we make some adjustments for that? There's ways to do that. Also kind of strength of schedule as well, right? If a team is just, we saw a talk this morning about, how much, a team's strength of schedule can differ from another, right? And if a team is constantly playing against good teams and are constantly having, being put under a lot of pressure, their pass selection is naturally going to be a lot different. Now, how do we, this is cool. This shows that it's, a fairly predictive way to kind of look at how a team's going to behave in the future. But like, how do we actually use this? So one way to do it is look at kind of team similarity. How am I doing for time? Okay. This is a simple kind of Pearson correlation matrix of each team, right? So you'll notice some clustering between certain teams. I'm missing a legend here, but the blue is a correlation of 1, and red I think is a 0, and so certain teams will say if I am Team J and I'm looking for maybe a player that plays a similar system to me, right? This is a great way to go out and do that, right? I say if I'm looking to recruit and replace a particular player, I'm going to be a little bit more confident when that player is coming in from a system and is comfortable playing in a system that's similar to my own. So yeah, just on a very basic sense, we can kind of look at team similarity. Now we can also, kind of in the particular kind of game-to-game types of analysis, I'm going to show you a handful of different kind of team-specific maps of clusters. So this, what this is doing, it's highlighting any of the particular passing clusters in which that team attempted a higher than 2 standard deviations from the league average volume of passes, right? So this particular team, these 3 types of passes, they attempt them considerably more frequently than the league average. Now, what you'll notice, what you kind of lose by looking at this as like a 1/50 vector is that like these things, these could be pass, clusters number 6 and 20 and 30 something, but they're actually quite similar in a lot of ways. So you see a lot of kind of spatial similarities in terms of, what types of passes teams are attempting more frequently. So this particular team, loves, long field switches from the left to the right. Now that could be, maybe they have a speedy right winger. Do they have, a center midfielder that's really good, or just maybe not good and just really likes hitting these types of, long passes, right? So that's actually fairly useful information to bring to a coaching staff, right? So it's not just, finding these particular things that teams are doing frequently. It's also finding decent ways to visualize that. Here's another team. This team, if you look at all of their different types of passes, none of them are particularly long. This is a very indirect style team. I believe this was the highest passing volume per game team in this league. And you can kind of see why. They're attempting passes that are frequently fairly easy, fairly short, and that's also fairly interesting for a coach, right? So the last, for this last one, we had an example of kind of a more direct team. This one's more of an indirect team, which are definitely kind of patterns and types of teams that you see. But you also see some teams that are not necessarily either of those, or maybe a mix, but actually are more kind of asymmetric in their approach. So this particular team, the 4 passing clusters that they attempt a really high number of are just on the left side. Now, why is that? It could be because they have a particular system that accentuates that style of play, or a particular player on that wing, or maybe a player that they should that they like to attack through, right? So these are all things that can help start to drive video analysis. It's like, oh, maybe this coaching staff wasn't necessarily aware that the team that we're playing against was really left side leaning, right? That can kind of cut down the amount of video that you have to watch, right? It gives you a little bit more additional context when you're going through those types of things. We can also, flip this too. I'm only looking at passes that teams attempt above average. We can also look at teams that are below average, in terms of certain areas. And what passes does a team not attempt ever? That's also probably just as interesting as this. And we can also use this defensively. We can flip this and say, these are the types of passes that this team tends to concede a lot, right? So say if a particular team has a defensive system that's seems to concede a lot of possession in certain areas of the field, this will show that as well, right? So understanding what types of passes that teams attempt frequently in what areas of the fields, and kind of the attributes of each of those passes are fairly useful for opposition analysis. So what else can we do with this? And the very obvious kind of next step is chaining these passes together, right? If we think of these different pass types and pass clusters as almost like words in a sentence or something like that, we can look at which ones frequently follow others and things like that. So we can kind of get a progression. And there's various things you can learn from that. So for example, this particular set of clusters going from is actually a very small pass during the right wing, but this is the most frequent passing pattern in this particular league that we're looking at. So this is a pass that has a pass along the right wing, which usually, that following pass, that's probably back to maybe a center defender or a right center or a right back, followed by a switch of play to the other side, right? So this is the most frequent pass in this league, but what you can start to look at is, while this is the most common for this league, what are maybe team-specific chains of passes that are more frequent, and why is that? We can also look at, okay, where are the most frequent types of pass chains that lead to this team's opportunities on goal, or which type of pass chains create disproportionately dangerous chances on goal, things like that. And what's really great about since we now have classified each of these passes, it's really easy to go and search through our database of possessions and find possessions that have this attribute. So, for example, here's another kind of animated GIF of, this was maybe 5 to 10 possessions that I just pulled out that had these 3 particular passes in a row. So it does a decent job at finding kind of similar passes, similar segments of passes. Now we can do all kinds of other cool stuff like this. So for example, we've started to plug these passes into a recurrent neural network that will help me classify certain things. So I've sat through and I've looked at a ton of video in addition to this, and I've tagged different possessions with different categories and things like that. So we're able to very quickly kind of automates our possession classification, which is great when you can scale that over not just our own league, but also all the other leagues that we're scouting for opposition, but also recruitment-based stuff. Other things you can do are kind of individual player tendencies. So I threw this one together kind of really recently, but this is a player comparison between, I think it's a right back and an attacking center midfielder at the same team, and they both played about the same amount of minutes. You can see that their passes per cluster are dramatically different, right? So you see a huge difference, obviously, in the types of passes that certain players attempt, but you can also, look at comparisons even inside positions, right? So say maybe I'm looking for an attacking center midfielder that has this particular passing profile. Maybe you're looking to replace them or find a similar player. You can very quickly go across your database, but looking at something like this and finding players that at least attempt certain similar types of passes and things like that. I think that passing types and how you kind of extend that is really pretty important in terms of kind of how you do different types of analysis at a kind of in an applied environment in a soccer team. And but in terms of things that I've kind of built with this and work with the coaching staff, it tends to be very very impactful in terms of they tend to understand this, especially when you're able to kind of put these maps of charts and things in front of them. It's just you get the buy-in a lot quicker. So that's all that I've got. Thank you. I suppose we can take questions or.
So we definitely have time for a couple questions. Any questions?
Have you thought of kind of putting so you're talking about from an offensive perspective, right?
Yep.
Passing of a team that moves on to attack. Have you considered putting kind of defenders along these pathways or and kind of try to see how that impacts the choice of a passing and
For sure. So what's tricky in our league is that we don't necessarily have this high resolution tracking data that say you have in the NBA or something like that. So for all of these, I actually don't know necessarily where the defenders are. You can do some kind of creative, modeling that will let you kind of guess where certain players are, given where the ball's been and where the ball is moving. So you can kind of imply. But no, we don't know exactly where the defenders are. But what you can do defensively is look at how, you know, if a particular team is, you know, has this particular system, you'll notice that, oh, maybe they're really good at stopping certain types of passes from happening and things like that. So while we can't necessarily attribute it to a particular player getting in the way of a certain pass, you do notice some like system by system differences defensively in terms of how this stuff looks.
So the defender's movement is not captured in outcome?
Not explicitly, no.
Any other questions?
Where do you see the future of soccer analytics?
Well, that's a broad question. Yeah, it's you know, just looking at the growth of the last 5 years, it's been exponential, right? I think that it's you know, we're at a sports analytics conference. We believe that this is the future, right? But you know, if we look at any sort of hyper competitive industry outside of sports, everything's gone the way of data, right? I think it's inevitable that, you know, soccer, given, you know, it's the largest sport on the planet, it's inevitable for this to happen too. But yeah, I mean, you face all kinds of cultural issues like you do in all the other sports, and I'm not going to bore you with that because I'm sure you've heard that story before.
Maybe one more?
Does the analysis also include dead ball situations?
The pass clusters themselves did not include dead ball passes, so I excluded all throw-ins and set pieces. But those can, you know, you can segment those and do, you know, a cluster analysis of those individually too. I think set piece analysis is obviously quite important.
Okay, let's thank Devin.